Hello, Luke. Welcome to Lesson 69. So today we have a fun and exciting lesson to get through. It's called Factoring Trinomials. And I would say this is probably one of the most important lessons we've had in a while. You'll be using this methodology and these concepts for years to come in your mathematical journey. All right, so let's go ahead and get started. I want you to get out your class notebook because there will be lots of notes that we'll be taking today. And we want to make sure that all gets in your notebook so that you can study it for homework and memorize the vocabulary so that it makes it easier to understand the problems. All right, so get that notebook out, get ready to write. And we're going to begin today off by just going through a few vocabulary words here. A lot of these are review, but I do want to make sure that you've got these down pat so that the rest of the lesson makes sense when we talk about these things. All right. So the first vocabulary word is the monomial. All right. So what is the monomial? And jot this down in your notebook. Again, if you have to pause the video, I would recommend actually you doing that. Pause the video, write down these definitions, then you can unpause the video, and then we can kind of talk about them once you have them written down. All right, so maybe just start right now, write down monomial and this definition, and then we'll come back and talk about it. All right, so what is a monomial? A monomial is a single expression of the form ax raised to the n, where a is any real number and n is any whole number. All right, so it's pretty straightforward. So this, for example, would be a monomial. If I have 3x to the second power, this is a monomial. You can see the different parts. You have the x, which, by the way, it doesn't have to be an x. It could be any variable. It could be a y, it could be a w, it could be a z. It doesn't have to be an x, but it does have to have a variable in there, okay? So we see the variable, that's pretty clear. The variable is being raised to an exponent, which would be the n, right? And that n is a whole number, which is part of the description here. So the 2 is a whole number, so that satisfies. And then finally we have this 3, which is standing in for this a right here. So you might think of the a as being the coefficient, the x as being the variable, and then the n as being the power of the variable. All right, we need all three of those things in order for a term to be classified as a monomial. All right, so my next question would be, is this a monomial? And at first glance, you might say, no, it's missing a bunch of pieces. But actually, those pieces are there. It's just it's invisible. So this is indeed a monomial. All right, let's think about it. Does it have the variable? Well, yes, it does. It has the x. Does it have the coefficient, which is the a? And in this case, it does. It's just invisible, right? There is a coefficient there, though. It's the invisible one. All right. Does it have the exponent for the variable? Well, it doesn't look like it does, but again, it has the invisible one. There's an invisible one right there. Okay. And once we see all of these invisible pieces, we can say, oh yeah, that is a monomial. It does satisfy all of the requirements. All right. Let's try another one. Is this a monomial? The number 2. Could that be considered a monomial? Think about that for a second. What do you think? Well, if your answer was yes, you are right. Do you know why? Well, if you don't know why, let's go through it. So how could this be written in this form? Okay, so the 2 obviously would stand in for the coefficient. That makes sense. But we don't have a variable, right? At least not one that's visible. We're actually going to place a variable in here. We'll call it the invisible variable. All right, and it's going to be an x. And you might say, well, wait a minute, Jim, we can't just add variables in there. That might change the value of the expression. And you're right, it could change the value of the expression. So we have to make sure that we justify putting in this x. Somehow we have to make this x null and void so that it doesn't affect the value of the expression. And that comes into play when we talk about the exponent. So what's the exponent of this? Well, let's make it the exponent of 0. Okay? Now picture that. X to the 0. Remember, anything raised to the 0 power except 0 is going to be 1. right? So x raised to the 0 is in fact just a fancy way of writing 1. And if I take a 2 and I multiply it, because there's again indicated multiplication here, if I take a 2 and multiply it by 1, I just end up with 2, right? So this expression, this whole thing, does in fact equate to just simply a 2. But it's a fancy way to write the 2, and if we write it this way, we're actually writing it as a monomial. So the number 2 is in fact a monomial. There's just a hidden part to it that we don't see. Okay? All right, so hopefully that makes sense to you. Let's give you maybe a couple of thoughts here on what might not be a monomial. So would this be a monomial? Let's say, 4. Actually, we'll write this maybe in a different color to show that these don't work. We'll go red. 4 times, let's say, x to the 1/3 power. Would this be considered a monomial? Well, it is not a monomial. And why not? Well, because of this little word right here, whole. All right? So the n, which is the exponent must be a whole number. And if we look at this exponent, it's a fraction. It is not a whole number. Therefore, this is not a monomial. Okay? All right, excellent. All right, let's move on here to the next definition, which will be easier, I promise. So the next one is a binomial. All right? So a binomial, you can see the word or the suffix bi in here, and bi indicates 2, right? Whenever we see bi, we should think of 2. All right? So this is a 2 monomial. All right? It's an indicated sum of 2 monomials. So, pick your favorite monomials. Maybe it's an x. Maybe you like the invisible parts. Or maybe it's a 3x to the 4th, something like that. All right? These would both be monomials. In this case, there are 2 monomials. Here is number 1, right? Here's the first one. And then here is the second one. We have 2 monomials, and they are being added. There's a sum here, right? Okay, so if it's an indicated sum of 2 monomials, it would be considered a binomial. So this is, in fact, a binomial. All right, and of course, we could come up with all kinds of binomials. We could say 3 plus 2, actually, is a sum, or is a binomial. A sum of 2 monomials. We could say 3x plus y is a binomial, okay? We could say, x raised to the n plus z. That's a binomial, okay? So these would all be considered binomials. Again, very simple. It's just the sum of 2 monomials. Very specific. It has to be 2. Has to be 2, all right? All right, let's go on to the next one. A trinomial. Well, now this one should be even easier because, of course, we see the syllable here, the suffix, or the prefix, the prefix tri. All right. And what does tri indicate? Well, whenever we see tri, we should think of the number 3. Okay? So we have a trinomial, a 3-nomial, or an indicated sum of 3 monomials. So it's the same thing as a binomial, except for now we have a third term. So it might be x plus 2x plus 3x. This could be considered a trinomial. It might be x squared plus 4x plus 6. This would be considered a trinomial, right? 3 different monomials being added together. All right, so that is the trinomial. And then finally, we have the polynomial, okay? Polynomial is basically the general term for the sum of any number of monomials, okay? So here we were very specific. A binomial needs to be 2 monomials summed together. Trinomial needs to be 3 summed together. Polynomial is a general term, and it just means any number of monomials that are added together is considered a polynomial. So you could argue that a binomial is a polynomial. All right? A trinomial is a polynomial. Okay? But there are also polynomials that are not trinomials and not binomials. And that would be cases where we have monomials that are more than 3. So if I have x squared plus x to the 4th plus x to the 6th plus 7. All right. This is not a binomial because there's more than 2. It's not a trinomial because it's more than 3. So this we would just call the general term a polynomial. It's just a polynomial. Okay. And that would be true if this were more too. I mean, we could have plus z plus 6x squared plus 7y. You know, anything we want to add on, these are all going to be polynomials because it's any number of monomials summed together. All right, very good. So again, I know I kind of just talked through all of that. If you need to go back and pause the video and just, you know, write down these different definitions if you haven't already as I've been going through it, do that now. Maybe throw a couple examples into your notebook so that you can see what they look like. And then we'll be ready to move on to the next part of our lesson here. All right, so now let's talk about, let's see, going here. Let's talk about trinomials. That is really going to be the focus of our lesson for today. So the monomials, the binomials, the polynomials, those are just vocabulary that we should know, but today we are going to be focused primarily on the trinomials. All right, now, as we pointed out earlier, there are many different kinds of trinomials out there, and we're going to be pretty specific today. We're going to be focusing on trinomials that are in this form, okay? ax squared plus bx plus c, where a, b, and c, maybe I should say that, a, b, and c are integers. Okay, so x's are the x is obviously the variables, but a, b, c, those are the coefficients or the integers in this case. Okay, so an example of the kind of trinomial that we're interested in would be something like 3x squared plus 2x plus 6. Okay, again, it's in this form. The A would be represented by the 3, the B is represented by the 2, and the C is represented by the 6. Right? And notice the practice here is to write these trinomials in descending order, okay? Which means that we write the term with the highest power first, followed by the term with the second highest power, and then followed by the term that doesn't have any variable at all. All right, that is the descending order. That's the general way that we want to write these down. Okay, so it'll be in this form. Now, to be even more specific, today in particular, we are going to be referencing or referring to this form where a is a 1. All right, b and c are integers, which we've already talked about, but in particular, today, we want to look at only trinomials where a is equal to 1. Okay, very important. Later on, we'll talk about trinomials whose leading coefficient, a, is not a 1. But that's for a future lesson. Right now, life is good. We're just going to make a equal to a 1. And those will be the trinomials that we will be interested in. Okay. All right, so that's kind of the setup for today's lesson, the groundwork on today's lesson. Now we're about ready to embark on the meat of the class. All right, so we've talked about monomials in the past, and binomials. Actually, I think we've talked about those in the past too. And we've even done some multiplication of binomials. And this should look very familiar to you, this particular product here, okay? We've often taken binomials and multiplied them by each other. And if you recall, and I hope that you do, recall that when we multiply these binomials, we use the method FOIL, right? The FOIL method. Okay, very, very important. It should be second nature to you by this point. You should be able to do this problem in your sleep. Okay, how do we do it? Well, by using FOIL. It tells us we take the first terms, we multiply them by each other. That gives us x squared. We take the outside terms, we multiply those by each other. That gives us a plus 2x. And then we take the inside terms and multiply them by each other. That gives us a plus x. And then we take the last terms and multiply them by each other. In this case, that gives us a positive 2. And as you've noticed probably in the past, often after we do the FOIL method, particularly with the problems that they've been giving us, because really the problems they've been giving us have been kind of, without you knowing it, preparing you for today's class. Okay, so a lot of the problems have been in this form. You may have noticed they hardly, if ever, have given you any problems that may have looked something like this. X squared plus z cubed times y plus w. Okay, they very rarely, if ever, I don't know if they've ever given you a FOIL problem that looks like this. It's always kind of been in the form of a variable being summed with a number, and then that's being multiplied by the same variable summed with another number. Okay, it's a very common way that they've been writing down your homework problems. And the reason is, again, they were preparing you for this particular class. All right, so anyway, when we're given this particular product, we multiply it out using FOIL. And you've probably noticed that usually these two middle terms are like terms, and they can be added together. All right, so our final solution here, our final product is going to be x squared plus 3x plus 2. Okay? All right, so that is just review. And again, you should be able to do that in your sleep. The whole point and purpose of today's lesson is to work this backwards, to reverse engineer it. All right, so instead of having two, and again, these are binomials right here, right? They're two binomials being multiplied by each other. And, well, what did that give us? That gave us this, which is a trinomial, right? Trinomial. These are binomials. Okay, just to use some of our vocabulary here. All right, so we have the two binomials being multiplied by each other, and that produces a trinomial. Okay, now again, the focus of today's class is to take this trinomial and try to get back to the product of two binomials. Get back to this position. All right, so again, we're working the problem backwards. If I give you this trinomial, show me the two binomials that you could multiply by each other to give me this trinomial. All right, that's factoring. That's all about factoring. All right, and that's what we would call this. We would say factor this trinomial into two binomials. Okay? All right, so how do we do it? How can we get from here to here? All right. Well, let's talk about it. Get that notebook ready because we're going to have a bunch of things to put in there. All right. So I will actually maybe just scroll this down to here. And why don't you pause the video? Just write this all down in your notebook. And then unpause the video and we'll go over it. And then we'll go to the next piece of the puzzle here. All right, so hopefully you have that all written down in your notebook now. The first thing that I'm noting here is that the process that we will be going through today only works if the leading coefficient is 1. Remember earlier, I said that it's, we're dealing with problems in this form. ax plus bx squared plus c. And I said we're really only interested in problems where this a is equal to a 1. That's what this is talking about. This whole process only works if the leading coefficient is a 1. All right. Now what I've done is I've just copied down this answer that we got up here after multiplying. I've placed it right here, and we're going to try to get back to the original problem. Okay. Which maybe you don't even remember what that was because I don't show it here, which is okay. All right, we'll check it at the end. So the first step is to just verify that the leading coefficient is a 1. So if we look at this trinomial, sure enough, the leading coefficient, when this is written in descending order, is a 1. Okay, so that is a big check mark. There we go. We know that this process then will work for this particular trinomial. So the first step is to really just know that, okay, what are we trying to do? We're trying to get it into a set of binomials being multiplied by each other. All right, so let's just set the parentheses up. We know this is what it's going to look like in the end. We just have to figure out what numbers and what signs go inside of these two sets of, these two sets of parentheses. Okay, so the first thing to do, step number 1, is square root the quadratic term. Now, I should have probably written quadratic in our vocabulary list at the beginning of the lesson. Quadratic is, if you don't recall, it's just a fancy way for saying an expression or a polynomial whose highest power is a 2. The highest power is a 2. All right, so if we have a trinomial such as this we could call a quadratic trinomial because the highest power is a 2. On the other hand, if I had something like this, x to the third plus 4x plus 7, okay, this would be a trinomial because it does have 3 monomials, but it is not a quadratic trinomial because quadratic always indicates that the highest power needs to be a 2. Okay, so let's just clarify that right now. Okay, so now let's get back to it. So the first step is going to be square root the quadratic term. All right, so where's the quadratic term here? Well, the quadratic term is right here, right? And so we're going to square root that. So what's something times itself such that it would equal x squared? That should be pretty easy. It's an x, right? X times x is going to be x squared. So what we're going to do is take those two factors, the x and the x, and we're going to put one factor in the beginning of each of our sets of parentheses. So there we go. That was painless. All we need to remember is to take the quadratic term, take the root of it, and place that root at the beginning of both of our parentheses. Piece of cake, right? All right, that's the first step. Now the second step, a little bit more complicated. Now we need to note the sign of the last term. So what's interesting is this trinomial, there are tons of hints, clues within this trinomial that tell us about the original two binomials. Okay? And the first sign, or the first clue that we're going to look at is the sign of the last term. The sign of the last term. This one right here. Okay? We're going to focus in on that because that sign is going to tell us something. All right? It will always tell us whether or not the two signs in our binomials here are the same or are they different. All right? Are they the same or are they different? Because remember, this set of binomials, it's going to be an x, plus or minus something times an x plus or minus something. We just don't know whether to use plus signs, minus signs, and we certainly don't know what the somethings are. Okay? So this, again, this second sign here is going to be our clue to tell us what these signs inside our parentheses are going to look like. All right? So whenever it's a plus, and actually I don't have that written down yet, that's in the next part here. But if it is a plus, that is always going to mean that the two signs in our parentheses are the same. Plus means the same. If this was a minus sign, then we would go to right here, this part of our steps. If it's a negative, then different signs are in the parentheses. So that would indicate that, if this were a negative, one would be a negative, one would be a positive. And it wouldn't matter where we put either one of those, okay? We could put it like this, or if we wanted to, we could put the negative first, or excuse me, the positive first and put the negative over here, okay? Either way, we could do either one if this sign was a negative, which it's not. It's a positive in this case. So positive indicates that these two signs are the same. They're either both negative or they're both positive. A negative sign here would indicate that the signs are different. One's a negative, one's a positive, and it doesn't matter which. Okay, so here, again, positive indicates that the signs will be the same. This sign now, we'll use this one. This sign also tells us something. All right, the sign of the middle term tells us if this is positive, which it is, then these two signs inside the parentheses are going to be this sign. Okay, that's the sign that'll be in there. Because remember, this one only tells us that the signs are going to be the same, but it could be two negatives or it could be two positives. This sign tells us it's going to be two positives. All right, so therefore, we can write two positives in here and say, there, we've figured that out. Okay. Very good. Now, I'm going to just maybe pause here for a second because I want to show you that whole rule right here. So you haven't seen this part yet. Why don't you go ahead and just pause the video and just write the rest of this down. You have half of it written down. You need to write down what happens if that second term's or the last term sign is positive. So write down this section right here. Okay, very good. So now you've gotten that all down. We can move on to our next step. So maybe what I'll do is I will just select this and we'll move it down. Maybe we'll just copy it and move it down because now we have step 3. All right. Step 3, by the way, is the last step, but it may be the most complicated step too. Oh, it's not going to work here. Do this. There we go. Okay, so we'll put this over here. Okay. All right, so let's just read through this step 3, and then you can write it down in your notebook, and then we'll use step 3 to continue working this problem. All right, so the next step is going to be write down the pairs. Emphasis on the word pairs here. That's actually important. The pairs of factors for the last term. So where's the last term? The last term is over here. Okay, the last term in the trinomial. We're going to write down the pairs of factors for the last term. Now, if the signs are the same, and this I have in parentheses in the previous step, so referring back to the previous steps, if the signs here are the same, which in our particular case they are, then simply choose the pair of factors whose sum is the middle term's coefficient. Wow, that's complicated, or at least it sounds like it is, but don't worry. As we do these, it'll be much easier as we start doing them. It'll make more sense. If, on the other hand, the signs are different, which again, they're not in this case, the signs are the same, but if they were different, and again from the previous step, then select the pairs of factors, or the pair of factors, whose sum is the middle term's coefficient when the sign of the middle term is placed before the larger factor. Okay, so complicated, but don't worry about it. Push pause, write this down, and then we'll actually do the work, and it'll make more sense to you. All right, so in this particular case, we say the signs are the same, so we're going to choose to do this part of step 3, okay, because they're the same. We're going to simply choose the pair of factors whose sum is the middle term's coefficient. Okay, so getting back to maybe the first part of step 3, this part, we need to first write down the factors of the last term. Now, the factors of the last term, well, the last term is 2. So if we think about 2, all right, maybe I'll just put a box around it. That's the number in question. we are going to try to find, or we are going to find, the pairs of factors for a 2. Now, that's different than finding the prime factors, okay? I'll say that right up front. You've been doing a lot of that. And this is different than finding the prime factors. We're actually finding the pairs of factors. So in other words, I'm saying 2. What multiplication tables will give me an answer of 2? Okay? And the easiest way to go about doing this is to start with the number 1 and keep progressing up one integer at a time until we find all of them. So if we start with the number 1, we would say, is 1 times something 2? Well, sure, 1 times 2 would give me 2, okay? And then I would go from 1 to the next integer. 2 is 2 times something 2. Well, yes, 2 times 1 is 2, but we already have that up here. It's just in reverse. So if we start at 1 and we work our way up, as soon as we arrive at a number that we've already found, we can stop, okay? In this particular case, 2 is such a small number, there's only one pair of factors that will work for a 2. It's 1 times 2, okay? So that makes it really, really easy. But later on, you'll have numbers like maybe 12, for example. And if 12 were the number in question, you'd have to say, okay, well, I have 1 times 12 would be a set of factors. I'd have 2 times 6, that would be a set of factors. I'd have 3 times 4, that would be a set of factors. 4 would work, 4 times 3, but I've already done 4, so I can stop. And so these would be the 3 pairs of factors for the number 12. All right, so you can see how we can get more. It's just our 2 is so simplistic. There's only one set of factors for it. All right, but we will have bigger numbers, so be ready for that. All right, so we have found the pairs of factors, and in this case, it's pretty easy. It's just 1 and 2. So 1 and 2 are going to go here and here because they are the only pairs of factors. But when we have more than one set of factors, we need to decide which set we're going to use. And that's where this second part of this first part of step 3 comes into play. So we're going to choose the pair of factors. Whoop, a little messy. Choose the pair of factors whose sum is the middle term's coefficient. So here's the middle term. I'll change my color here. Here is the middle term right here. Okay? And we're going to look at the coefficient of the middle term, which is a 3. All right? And we need to choose the pair of factors such that if added, not multiplied, but if added, they equal the coefficient of the middle term. So does 1 plus 2 equal 3? Yes, it does. So therefore, the 1 and the 2 are going to be the coefficients or the factors that we will plug into our parentheses. And we end up with x plus 1 times x plus 2. Okay? Now, this may seem a little intimidating at first. Don't be afraid of it, though. It's, once you get into a rhythm here and you've done enough of these, a lot of this work you'll find you'll be able to do in your head. Okay? But it is very important to take it step by step and follow this 3-step procedure to get back to the binomial, which in this case is x plus 1 times x plus 2. And if I go back up to the original problem here, what did we have? We had x plus 1 times x plus 2. All right, so indeed we did reverse engineer. We started out with this trinomial and we worked our way back up to the binomial. Okay? All right, now what I'd like to do is we're going to go to some problems, and I want you to keep your notebook handy with all of those steps written out. So that's right there in front of you, and we will be doing those steps as we work these trinomials. All right, so let's try this first one here. So we have a trinomial, and let's say they tell us to factor this. Factor. Okay, which means we want to break this up into a product of 2 binomials. All right, so we know that this is going to end up looking like this with something inside these parentheses. So let's just write the parentheses down first. I guess that's, the first step. Okay, now we need to look at our x squared. Now, if you look at your class notebook, remember the first step there was to square root the quadratic term. So this is our quadratic term. We square root it, and we place that at the beginning of each of our parentheses. So we have an x. That's an easy part. Now, the second thing is going to be to look at this last term's sign. Okay, this last term's sign. Its sign is a positive. Now, if you look at your notes, if the last term's sign is positive, that would indicate that the signs in our parentheses are the same. So they're either both positive or they're both negative. To decide which, we look at this sign. This sign clues us into which one we're going to use. So they're the same and they are positive. So we're going to put a positive in both of our parentheses. Okay? Now we move on into that step number 3. And the step number 3 tells us to find the factor pairs for the last term. So the last term is 6. That's our number in question. And what are our pairs of factors? And again, we're going to start with the number 1 and work our way up. So we have 1 times 6. That works. 2, yes, 2 times 3 will give me a 6. Great. Now we can go to a 3, and yes, 3 times 2 does equal 6, but we've already done a 3. A 3 is right here. So we can stop. All right. So those are our 2 pairs of factors. Now we need to look at which one of those, because these signs are the same, okay? These signs are the same. So which one of these will add up to be this middle term? Okay, 1 plus 6 is 7. That's not the middle term. 2 plus 3 is 5. That is the pair that we want. That's the pair we're going to use. And since our signs are the same, it doesn't matter where we put them. I mean, I could put it here, a 3 and then a 2. That's fine. Or I could put a 2 and then a 3. It doesn't matter. We're just... it's like saying, is 3 times 4 any different than 4 times 3? No, we can flip-flop those around. It's not going to change anything. All right? So don't worry about where you're going to put them if the signs are the same. If they are the same. Okay? And there we go. That is our factorization of this trinomial. Not bad, huh? All right. Let's try another one. All right, so again, we know that this is going to be a set of parentheses that looks like this. And our quadratic term is the x squared, so we'll square root that and get an x to go in both of these. I should probably point out, too, that the leading coefficient is a 1. If it was a 2, which they're not going to do that to you right now, but if it was a 2, you would have to say, I don't know how to do this yet. Okay? But because it's a 1, we do know how to do it. All right, so we have an x in each set of parentheses. Now we go and we look at that sign again, right? We look at this last sign. And this one is different than any of the other 2 problems that we've looked at. This is a negative sign. Negative means opposite. Remember that. Negative means opposite. So because negative means opposite, we're going to have opposite signs in our parentheses. So we're going to have a negative and we're going to have a positive. And at this point, it doesn't matter which one you write first. You could write positive and then negative, or like I did, negative and then positive. Doesn't matter. Okay? So notice I didn't even need to look at the second sign yet. All I need to know is that they're going to be opposite. Okay? Now, this other sign, since that's kind of the step we took last time, this other sign does still clue us into something. All right? Does still give us a clue. That sign will go with the larger factor. All right. I'll say goes with the larger factor. All right. Look at your notes. And well, if I go back to our notes here, whoops, too far. Here. If the signs are different, step 3, if the signs are different, which they are in this case, then select the pair of factors whose sum is the middle term's coefficient when the sign of the middle term is placed before the larger factor. So all that means right there is that we're looking at this problem and we're saying this sign, the middle term's sign, will go with the larger factor. Okay? So just kind of put that in the back of your mind. The negative sign is going to go with the larger factor. Okay, now we need to do our factors again, our pairs of factors. In this case, it's for 18. So let's find the pairs of factors for 18. What do we have? We have 1 times 18, 2 times 9, 3 times 6, 4 doesn't go into 18, so we can skip it. 5 doesn't, 6 does, but we already have a 6, so we're done. So we have 3 sets. Okay, now which set are we going to use? Well, before we start adding, because we're going to use the same process, one of these sets is going to add up to be this middle term's coefficient. All right, we're trying to get to a 3. Okay, but because these signs are different, we need to decide which one of these is going to be negative and which one's going to be positive. All right, because they're different. They're not going to be the same like they were in our other problems. So what did I say earlier? This first sign, the sign of the middle term, it goes with the larger factor. So really you can then go through your factors, and for all of your larger factors, throw in a negative sign, because we know that this negative sign is going to go with the larger factor. And now, knowing those are negative, that means that these ones are positive because they have to be different. We can now sum them together and try to get our 3. So what's 1 and a negative 18? Well, that's a negative 17. That doesn't work. 2 and a negative 9. Well, that's a negative 7. That doesn't work. 3 and a negative 6 is a negative 3, which is exactly what we're after right here, a negative 3. Okay, so this will be the set of factors that we will use. Okay, and again, we've got, let me put this in red. The 3, or I'll start with the negative 6. The 6, which is the larger number, gets the negative sign, so the 6 is going to go here with the negative sign, and then the 3 will go with the positive sign. And there we go. We have now factored this. It's always a good idea to double check your work here at the end. So once you're done, just do a real quick FOIL and make sure that we get back to the trinomial. All right. So if I do FOIL in my head, I'll have x squared, and then I'll have the outside term plus the inside term. So I have a negative or a positive 3x and a negative 6x. That's going to give me a negative 3x. And then I have my last terms, which is a negative 6 times a positive 3, which is a negative 18. And if we look at this compared to our original trinomial here, they do match. So therefore, this is the correct answer. All right? Okay, so again, if you're struggling with this, it's going to take practice. Keep that sheet open so that you can follow the steps, and just practice, and it'll come to you. It'll become second nature as you do more of these problems. All right, let's move on. Let's try another one. So here you go. I think you're ready to spread your wings here a little bit. Why don't you pause the video, try this one on your own, and then we'll do it together. All right, let's see how you did. So we know we're going to have our set of parentheses, our binomials being multiplied by each other. First step, find the quadratic term, square root it. It's going to be an x. Second step, let's look at our sign for the last term. The sign here is a positive, which, I don't know, I always like seeing positive. It just makes it easier, I think. So we know that these two have to be both the same, and because this sign is a negative, we know that they will be negative signs. We're going to have 2 negative signs here because, again, this one tells us that they're going to be the same. This one tells us what they're going to be. Okay? All right, so we have our signs figured out. Now we need to take that 16, the last term, find our pairs of factors for it, and it's going to be 1 times 16, 2 times 8, 3 can't, 4 times 4, 5 can't, 6 can't, 7 can't, 8 can't. We're right back to where we started, so therefore we've found all of them. Which one are we going to choose now? Well, we need something to add up to an 8. All right, so 4 and 4 is the 1. 4 plus 4 is 8. Okay, so we'll put our 4 here and our 4 here. Okay. Now let's just do a quick FOIL check. Make sure that we did this correct. We have our first x squared. We have our outside negative 4x plus our inside negative 4x, which is going to be a negative 8x. And then we have our last negative 4 times negative 4, positive 16. And if we compare that to our original problem, it matches. So therefore, this is our correct answer. We could even write this as x minus 4 squared. Be another way to write that. All right. Very good. Let's try another one. All right. Pause the video. Try this one on your own. All right. Let's see how you did. So you've got our set of parentheses. Square root the quadratic term. We have x's. Minus sign. That's going to tell us these signs will be different. Remember, minus means opposite. So they will be opposite signs in here. Doesn't matter where we put them. We'll just go a negative and then a positive sign. Okay. This negative sign here indicates that the larger factor is going to be a negative number. And then this 15, we're going to break that down. So let's break it down into its pairs of factors. We have 1 times 15. 2 does not go into 15. 3 does. 4 doesn't. 5 does, but we already have a 5, so we're done. All right, so now the negative sign has to go with the larger number. So we'll just put our negative signs in over here. Negative, negative. And we'll combine these. So 1 and a negative 15, well, that's a negative 14, which is actually what we're looking for. Is that 14 right there? So this is going to be our set of factors that we will use. So again, the 15 goes with the negative sign. So we'll put that 15 right here. And then we have the 1 over here. And again, let's just do, a sanity check here. Just make sure that everything is the way it's supposed to be. If we do a FOIL, x times x is x squared. We have our outside, which is going to be a positive x. Our inside, which is going to be a negative 15x. Positive x and negative 15x is a negative 14x. Negative 15 times a positive 1 is a negative 15. Bingo, that does match with this. So therefore, our solution is this one. Okay? Very good. Excellent. We'll try one more, and then I think we'll have to stop, and then you'll be on your own for your seat work. Keep that notebook in front of you so that you can follow these steps. Okay? All right, so pause the video, try this one on your own, and then we'll do it together. All right, let's see how you did. So we have our set of parentheses. Square root the quadratic. That's an x. This negative sign indicates opposite signs in our parentheses. We'll put a negative and a plus. The 10, let's take the 10 and break that down into its pairs of factors. We have 1 times 10. We have 2 times 5. 3 can't, 4 can't, 5 can, but we already have a 5, so we're done. Which one of those, now remember, this is opposite signs here. So we have to look at this sign. This sign will indicate the sign of the larger number. So over here, we can just, write in our plus sign next to the larger numbers. Okay. Now the thing to recognize here is because these are positive and we know that they have to be opposite signs, we can also write in negative signs here. So if the larger ones are positive, then the smaller ones have to be negative, right? So don't forget that step. That's important because again, they have to be opposite signs. So we know the larger one because of this, the larger one is going to have a positive, but that means the other ones must have negatives. All right. So what do we have? Negative 1 plus 10. Well, that's positive 9. That's not a 3. And then we have a negative 2 plus a 5. Well, that actually is going to be the 3. So that will be our set that we're going to be using. So the negative goes with the 2. Positive goes with the larger number, which is the 5. And there we go. Quick check. Do our FOIL. X squared. Outside term is 5x. Inside term is negative 2x. Combine those and we get 3x. And then the last terms, negative 2 times 5 is a negative 10. And bingo, that matches. So our final solution is, in fact, this binomial, or product of binomials. All right? Excellent. Very good. Well, actually, I do have one more. Oh, I've got a couple more here we could do. Well, I think we're a little short on time. I'll do this one. I'll do this one. This one, go ahead and pause the video again, and I just want to see how you react to this problem. So look at it, and if you're stuck, unpause the video, and we'll go through it together. All right, so the interesting part about this is that it is not written in descending order. All the other problems were. So if you have it like this, where it's not in descending order, the first step actually becomes write it in descending order. Okay, so let's do that. We need to first find the term with the highest degree or the highest exponent, which is going to be this term. That's the term that's going to go first. And then we'd write from there our next highest degree term, which would be the negative 5x. And then we have this leftover term at the end. Okay, so this is the proper order in which we should write this problem. All right, and if we see it in this problem, in this way, we recognize the old familiar pattern. And we also should recognize that the coefficient for this x squared is a 1, which is necessary at this point. All right. Okay, so once we've gotten it to this form, the rest is the same as usual. We have our parentheses. Take the square root of x squared. That gives us x. This positive sign indicates the signs are going to be the same, and they're going to be negative. So we have negative signs. We have a 6. If we take that, break it down, we have 1 times 6, 2 times 3. Those are the only two. Which one of those will add up to be our middle term here, our 5? 2 plus 3 is going to give us a 5. So we have a 2, and we have a 3, and there we go. And if we check this, we'll find that it's going to be equal to x squared minus 2x minus 3x, which is minus 5x, plus 6, which works out. Okay? Very good. All right, so hopefully this is kind of starting to come together for you. Again, it'll take some practice, but you'll find that eventually the goal will be to take this, x squared minus 5x plus 6, and recognize in your head that this is going to be x, a 3, a 2, and it's going to be a negative and a positive. I'm sorry, a negative and a negative. Negative and negative. To be able to do that basically in your head. Okay? Excellent. We will stop here for today, and we will pick up on this in future classes as well.